Okie dokie. Da-da-da. All right, we are live. Good morning, everybody. It's Alex. Welcome back to Handmade Zero, whatever, to the Handmade Game Dev stream here. Not affiliated. I don't, what? It doesn't really matter. But anyway, if you want to join me, we're working on the Mac port of my fun game today, and we've got some tea to sip. So let's do that. Delish. Okay. All right. Uh, this is where we are right now. Unfortunately, it's kind of a mess. This is our entry point into the Mac version of the game. We're on Mac today. We've been able to build an app bundle. We've been able to build an executable that opens a window, just using all of like the AppKit Cocoa stuff. The next level on top of that, however, is to get things actually rendering through the Metal API. And this is a lot more complicated than just opening up the window. And unfortunately, it's a lot more complicated than kind of just writing a direct port of all the direct 3D code I had. I have discovered that Metal does not let you do things in immediate context for the most part, like D3D does. So if we were to look at my D3D11 code, we have all the shaders. We have our sort of like create device function here, where we go allocate all the memory, create back buffer, RTV, all that fun stuff. But when we go in to actually render stuff in our main, or in this DX11 render function that actually calls the is called in the main render loop of the game, this is doing all stuff in immediate context. It's doing mapping stuff into memory, the vertex buffer, and creating that. It's going and grabbing the sprite atlases and the font atlas that we have sent over to the GPU in the immediate context, as well as our linear sampler. It's setting the vertex buffer layout and the stride, all this stuff, as well as the shaders. Again, all in the immediate context, and then we draw like so. The problem we've got here, and it is a big problem, is that Metal does not have or does not expose the ability for you to do drawing in immediate context like this. You have to use a either it's a command queue or some sort of Metal buffer, and essentially you are batching a bunch of draw commands per frame to go in and redraw all the pieces of the scene. And there is where you want to be a little bit smart about it and try to batch things as much as you can, use as few of these draw calls, do things as very smart. And my game side logic that actually has been going around creating like our quad buffers memory, figuring out how to, and then going into the direct 3D layer and actually going and turning that into a bunch of into the vertex buffer. That is not going to just work to get things rendering in Metal, unfortunately. So there will be a number of fun changes to make along the way to just like kind of get this to work. So kind of at a crossroads here. Still have the ability to just go ahead and go ahead and like try to cram a bunch of stuff to make it work here. I'm again going off of Ted Bendixon's 2D pixel art game template for Mac. He has graciously open sourced that code that allows you to do a bunch of this Mac stuff, Handmade Hero style, with the Metal render API. but I didn't realize until I really looked through it that his whole setup is orchestrated around doing things in this command buffer style, which is totally not what any of my code is set up to do. So we're trying to bring that in, as well as just trying to get fix or get basically everything to just compile as is, and get it to start working. So here's like my very first problem. This is my like types CPP file. This is a C++ compiled file or object, right? And so this is kind of like just the big master header for everything in C++ land here, where all of our different types are defined, all of the different data structures that we're using are in, and basically everything's downstream of it. It's also the common one place where I'm trying to have all of like, libce headers, as well as Windows and Apple headers living in. The problem, though, has proved to be this is trying to be compiled as C++, right, by Clang, but all of the Apple frameworks that we're trying to use, and right now that is mostly AppKit, as well as Metal and IOKit for doing I/O. These things all want to be compiled as Swift or Objective-C, basically, right? Or I guess this one is like a C interface. So right now we're having some problems basically, where if we try to compile, you'll see Clang gets really mad at us. It's like, hey, all of these @ and all this like garbage are totally invalid C++ syntax, because they are, and somehow whatever we're doing right now is not relaying the message that this part of stuff needs to be compiled either as Objective-C or as a straight C interface that like the C++ code can go into. So this is also a problem to solve, and I think it is a much more self-contained one that we really need to get working. The big thing that I would like to do is fix this, so that I can start actually pulling in a bunch of my real code from the rest of like my Windows version of the game. So from like here, or well, not directly this one, but like my own OS interface layer and my graphics abstraction on top of the render API. These things I really want to be able to start hooking up to the Mac OS and Metal versions of things, so that I can actually see it actually going in and trying to make it work. I can see what the problems are, where I made some wrong assumptions, and what needed to be abstracted out, or what is not actually going to work. What assumptions are just totally wrong when trying to go from one platform to the other, like this Metal command buffer thing. So I think it's kind of critical to be able to compile to the rest of the code actually before just trying to take a stab at a like Metal rendering loop in isolation, because I think that is a useful exercise, but we're also trying to get it to work in this integrated manner, and if we delay that, then we're going to be spending a bunch of time we could be spending a bunch of time doing things that are just not going to be working and have to redo it anyway, right? So may as well get the integration step over with. So let's try to figure out what exactly they want us to do to cross compile, or not cross compile, but like to get Objective-C code and working with the rest of our C and C++ stuff. So we will go back to Ted's code here, and he is compiling everything in C++, right? So that's good. That's what we're doing as well. The question that I've got here, and I think I know the answer, is I'm pretty sure the way that his build is working is he's got like this build shell script here. And what that is going and doing is actually building. If we look at the Clang invocation here, it's building with the entry point as that OSX main the Objective-C file, and then that is including all of the C++ and C code underneath it. So I just want to verify that that is actually the case. So there is some, these are all like helpery type stuff, but it does seem like there's a bunch of C++ code, and here it is, game library, game CPP, game main CPP. It looks like it's pretty safe to just include C++ code into an Objective-C compiled file, right? I think that is just how it works. I'm also, I think, one thing about like the file types, I think the .m's are actual Objective-C, and then the mm's are maybe Objective-C++. So that could be, that may be something very fast to just go try to see if that works. When we're in like the middle of LLVM hell here, of who knows, like right now, like what is going on, and the person should be me, but we need to, oh, that's not gonna work. Apple types.m, it's right there. No, it still doesn't like it. That does, no, it still does not like it. Yeah, and so this top error here, that I think is just from like the types pragma like not working, or the types include not really working correctly, and then it just drills down. And then we have like the real error is, again here, where we are not able to compile the Objective-C syntax stuff. So I think, I've been trying to do everything source file only. One thing to try maybe to move, our Apple include header, like really our Objective-C thing, into into just like a header file, and then try to include from that. I did it again. I did it again, ladies and gentlemen. If we do that, will that just work? No, it still does not just work. So one thing to try is from there, go create a, like Apple types.c or something that is going to just, we do like once, should include Apple types.h, right? So let's see, does that just work? Also, what? P restart. I think someone deprecated that, unfortunately. That's really annoying. So let's look here. If we look at our types header, does this still throw an error? It sure does. Yeah, so let's ns obj runtime.h. So if we like look through, it's going to be a couple layers deep, unfortunately. So how can we go about doing this? This is like a really stupid, annoying problem to have. But actually, this is kind of what you do, I think, if you're using any of the other LLVM based programming languages. Of there should be some kind of way to do like an interface. I think it might be something like, you have to do like the wrapper that tells it that it's like C code. And we can ask our friend Mr. Grok over here what the skinny is. How to include appkit.h in my cpp file. And let's see if it can figure that out. Yes, so rename your file to mm. Okay, so that is that's what it wants you to do. Yep, do the linker. Treat a file as Objective C++. Ah, oh, interesting. So that may be, something we can do. We can do that. I'm kind of okay doing that. Let's see. Why not? Let's see if that works. The annoying thing is that Clanged will not pick that up unless we tell it to, but oh well. So let's actually just do include appkit / appkit directly here, and we'll see if that works. Oh, objection. No, this is not this is not the correct thing. Okay, here we go. That kind of looks different. Yeah, that actually looks like all of the errors we expect from right now. So that's pretty cool. That actually is that does look like it worked. The only thing to be wary of here is we just changed the entire compiled language of or like target language of what the thing is compiling to. So good chance like some creepy stuff could slip in, because we're going to be we have the option now of mixing like C++ and Objective C++ syntax like in our stuff, and like right now it'll work, but then as soon as we jump off of Mac again, those things very much could all start breaking. So it's a very gotta keep an eye out for that. So one thing I would like to do, or else it will drive me crazy, is see if we can fix Clanged here on Mac for us, so that it doesn't just do that. So we'll do like one that's like is Mac has Mac, is Mac or right like so. Okay, and then we'll grab like one of these. Oops. Okay, and then yeah, that's clearly wrong. Let's see. So let's look up like Clanged config. If we can't, or you know what, oh, here we go. Compile flags. So let's see. Compile flags. -x Objective C++. Yes. And let's see if that works. Now we will have to relaunch because my thing does not source stuff very well right now. So Clanged still not liking that. Let's see here. Do Clanged compile flags. Yeah, it's all that stuff. So the problem is, so I do have like the source kit LSP. This is really annoying, but it's something I want to have. I definitely want to have working before I go offline for a couple weeks. Is so the source kit LSP will handle um like Swift and Objective C code all correctly. I suppose I could do that and turn off clanged for right now. Um, that might be the easiest thing. Let's see if we can do that. So we'll go back. Let's get rid of that crap. This might work. That might just work though. Clanged use C on Mac. Fix this. You know, we do one of those. Because like this is probably wrong. And then I don't, you know, it didn't look like, you know, I couldn't see if this was actually getting passed into that check health there. So let's see. Yeah, let's see, that didn't really, oh, created .clanged file. Yeah, that may be, that may be the smart thing, right? So we should probably just do that now. Yeah, let's do that. That it's a little annoying because, you know, we will have to do that kind of in a bunch of spots. So let's go here, but hey, it's better than like fucking around with that, screwing around. Sorry. Do get rid of that. That. Or H, I guess, or CPP, or yeah, we kind of do want all of those. Okay, and is there anything that I broke in here? How do I diff this again? Let's see. Oh, Tom Daya FC shouting out. Yeah, there's your shout out. Okay. Yeah, let's just get rid of that actually. How do I is there a restore here? No. Okay. Let's just go in and get, let's just blow that away. Alright. So with this clanged, okay, this clanged will not work. Will certainly not work on Windows, but oh well. We are not going to be on Windows for a little bit. We go in here. AppKit not found. Did not find header, AppKit, framework, AppKit. Yes, you're welcome. You're welcome, Tom Daya FC. So what is up with that? So it must be the clanged that, oh god, that freaking broke again. I'm sure this like does not work. That may be broken. Yeah, that looks like that was totally it. So, and we are able to still compile without getting all the Objective-C syntax errors. Okay, we are. So that is awesome. That is super cool. I'm gonna commit that because that is definitely worth not losing. back with the 5-minute streams. No, we're on till 8:15 today, so should be good. So we'll add the clanged. We definitely need to fix that somehow. Okay. Got obj C++ compiling with LSP, so that's good. We kind of needed that .clanged file, I think, for a while too, so that's good to add it. Okay, so here we go. Now we can go in and start doing some fun stuff here, and also I can probably get rid of this and this, so that's good. So this one is doing that, which is good, and that is all the errors we wanted to have, also good. So let's look in here. So I think we also want to include metal / metal, and then the IO kit, right? / IO kit. Does not look like it was that one. Let's see. If we look over here, you definitely want to bring that back. /hid / IO hit lib. Okay, cool. So we want that one for sure. That one is it. Oh. Okay, cool. Alright. Now we are all square there. So now we can actually go fix this stuff here. This macro is wrong. Unknown type name metal texture. Are we not pulling that in? Oh, is that a metal kit? That may be for metal kit. An MTL texture exists where? Let us see MTL texture. So this, I think, MTL texture. No, this is in metal. The metal kit. Or the metal framework itself. This should be the thing that we're binding in the GPU that has the, like our sprite sheets or whatever in it. It is what I'm assuming. Yeah, it looks like that's some min versions of these platforms that it's going to support, something like that. Okie dokie. So, why does that not just work? Because, like, what up? What up, dog? Why does that not work? Unknown type name MTL texture. Am I just like stupid? Did I spell it wrong? No, didn't just spell it wrong. Oh no, math, yes. No, we're not even doing math today. Today is still just like, today is doing a bunch of stupid if-def stuff. is trying to resolve that, so this at least compiles enough to get us to like the next step of things. I'm gonna go grab my tea really quick. I'll be right back. Okay, and we're right back. So, a couple things that could be going on is, we are here, like, this may not be a C++ type that I can actually go if-def around. No, I had it brewing already, so we just had to do the pour. So that was good. So because this is like an app protocol, which looks like, and I'm no Objective-C expert here. That looks like an interface or some sort of like template stupid thing. This is like on top of a metal resource, right? Because like Objective-C has its own stupid like object inheritance model that is separate from C++, right? And we are just stuck living in that world. So it's very possible that that is not actually a type. That is not a real type that we can type def. We can see if the, you know, our LSP also cannot find just MTL texture actually. What about MTL texture type 2D? Oh, nice, man. That's awesome. I'm glad that you scored well. Let's see. No, this is like just an enum. That has nothing to do with what we are trying to do. All right, let's see here. In C++ code, use MTL texture. Should have won every category. No, for sure, dude. The no, the pixel art in that game was really cool, and I did like it. It was a very cool looking game. Some cool levels and stuff, and like quite a bit of content for a game jam release. So I'm sorry it didn't go better, but still pretty cool stuff. All right, let's we have to switch over to to thing number 2. You know, thing number 2. Here we go. Okay, so let's try that. Yeah. Yeah, so Objective-C protocol is not a real like class. But I do. Oh, I see. I could have like some sort of like have it like point to the thing. That is quite irritating. Oh, metal CPP. Oh, see, now that I would much rather be using than doing this screwing around, right? So why can't we find that? That would be much better to actually use like the real bindings than do all this nonsense. And like, hey, if we can even do that at the Cocoa level, that might be nice. Maybe nice. Access the headers from GitHub. Oh. Okay. Generate the implementation. It's a header-only library, and it's going to go do all of that nonsense. Okie dokie. Okie dokie indeed. Follows the object of C++ object. Yeah, that. I mean, this looks like it is potentially reasonable, but I am a little suspicious here of pulling this in as like an extra library. What's up, the code guy? How are you doing? We're working on some fun Objective-C stuff right now, which is awesome. So it is doable. We could do this, but I don't know how much I trust it that how much I trust this that it's actually doing all of like the memory management the way I would want it to. and you know that it's like fully abstracting all of like the metal stuff like directly. So let's go just grab that, because that is definitely worth checking. C# Game Dev Raylib. That's awesome, bro. I have heard great things about Raylib. I have not used it myself, but Ray seems like a cool dude. He's always shit posting on Twitter. Yeah, I think this is the first time I've gotten the YouTube and the Twitch chat going at the same time. So this is a really big moment for me in my streaming career here. Okay, so where did that thing we just downloaded go? There it is. So what the hell did just happen? Okay, didn't like that. So this is the thing we were just looking at. And here are, yeah, this does look like every single header, but as an HPP. So that's cool. That's cool. So in doing this though, also have to consider like, is this really solving the problem? And it might be, right? Because the thing that we really want to be doing is, yeah, the thing we really want to be doing is have as much stuff live in the C++ like game code that I own as possible. In one way or the other, we are going to have to use the Metal Render API, right? One way or the other. So the goal of pulling this in should be to avoid some kind of to avoid polluting the common game code with too much stuff that is going to pull it into like Objective-C land, because that is not what every other platform code is being written to. Every other platform, we're trying to be in do things in C++, right? Or compiled in C++, mostly just writing C code. But again, we also are trying to have as thin of these platform layers as possible, and pulling in this giant additional wrapper here. I don't know, and I'm not confident enough in like all the stuff that's going on here to tell you if this is a good idea or not. So, you know, we have a bunch of the foundation stuff in here, but it's not complete too. You know, we're like, there's no like NS window, it looks like, or something like that. Oh my lord. Oh, they have oh no, I have in SoCal. Because I'm in the wrong folder. What were we looking for? NS window. You're dumb coder? Oh man, that's no good, bro. It's being a coder is about being dumb sometimes though, to just get the thing done. But it does not look like there's an NS window. Is there? But let's look at. Is there a Cocoa CPP? It's very possible. Is this the real Cocoa? C++ with Cocoa. You cannot write a Cocoa application entirely in C++. Yeah, and that's the problem. Is like, okay, you know, we can do this on the, like, do a bunch of metal stuff that is, you know, in C++, right? But the reality of this platform too is that it is all working in Objective-C, or Objective-C++, right? And the further we go away from what the platform actually wants, then you know, the more surface area there is for doing like this translation layer crap, right? So we're like at a very annoying spot here, trying to split the baby and get it to work. I don't know, my chat thing is not. Refresh this. Oh, thank you for the sub, bro. I appreciate it. I have to ban these AI keyword things though. Man, it didn't work. Yeah. These things are so annoying. Get one like every day, basically. Alright, we got like 5 minutes here. So let's look up. Let's try to understand what it is we need. So, and that was kind of the point of doing things this way. So let's not do that yet. So I have this object or this struct called a graphics image. This is no, I won't ban you, bro. This struct is meant to be in my game's memory, the object that sort of stores like a sprite sheet or a font atlas, any sort of thing that is a binary image that we use to draw stuff that we're pushing to the CPU or to the GPU to render, right? And so it has, it's got itself, it's got like an allocator, so where it is, it's got some metadata about the image itself. It has a handle to the GPU object. So with D3D11, that's the shader resource view. Am I smart coder? I hope so. I hope so one of these days. I try my very best. Like no one ever did. And then we have a handle, the render target handle. Here is, I don't know if we actually use this because this would be, I know in D3D11 you do. Oh, I think we. Oh wait. In D3D11 you can like draw stuff to a texture basically, and do things there. Oh, we're never using this. Oh, that's awesome. I don't have to deal with it. I'm gonna get rid of that because it purely is just dead code. And anytime you can delete dead code, you should. Is what I've always learned. Okay, so that's cool. That's one less thing. So yeah. But we do need or we would like to have a handle to this thing, and what we do right with this this image is in our graphics layer here. We have, oh my god, this thing has a bunch of Win32 types in it. That's unfortunate. No. Okay. Oh, why am I double doing that? Okay, yeah, this thing has a bunch of Win32 types in it. Oh well. But if we look at here, graphics init image, this is where we actually go pull the image in from the OS file system into memory, right? Or actually, no, sorry, that's not quite. It is this one, load image from disk. So you'll see, we call a file that's just like a function that reads the file into memory, into this PNG struct here. We're only supporting PNGs right now, so oh well. Then we we take from that PNG buffer, we dump that into Sean Barrett's library STB image, and what that does is it actually goes and does the PNG decoding, and it will strip out the header metadata, and it will turn it into an actual big memory blob that has all of like the pixel values with all the channels and stuff. And then from there, that's what we dump into this graphics image. And in the direct 3D11 case on Windows, we set a bunch of metadata that it wants to have to control this thing, and then actually go, when we run this method here, create texture 2D, that sends that that image memory over the wire to the GPU, and then it just stays there. Yeah, this is my game from scratch. I'm trying to use basically no libraries to do this. This is mostly all my code at this point. We're building up the Mac stuff, but the Windows layer stuff all kind of just works right now. The only libraries we're using are just the platform ones that we're stuck with. So the render APIs, the actual platform OS stuff, as well as 2 libraries to handle some file formats I didn't want to write parsers for. So that's STB image and STB TrueType. So image loads PNGs, TrueType loads font files. That's pretty much it. Anyway, I think unfortunately we've run out of time here. The point though is the point though is we probably need to be looking into this graphics layer to figure out what the heck we actually want to do, as well as into here to see what happens in a working example of actually sending a metal texture to the GPU, if that is indeed how it works. Because again, metal has some differences from what you can get away with in D3D11, and so it's very possible that on each draw call in metal we will have to send the like the texture over the wire every time. I am not familiar enough with this API or this architecture to tell you, but it's something that we've got to figure out. So thank you very much, guys, for watching. I hope that was interesting. Somewhat, I know, a little bit slower part as we come up to speed on all of the Mac and Apple stuff, but actually so huge that we did some Apple type stub code so huge that got the Objective-C++ compiling and working in the LSP, because that is like just gonna save me so much headache of being able to actually find like where the stupid code is breaking, and not be guessing. So farewell for now. I hope all of you people have a very wonderful rest of your day, and I'm gonna go drive to